So last lesson we're going to look at is Law of Cosines. So goal here is pretty much the same as what we've been doing. We still want to find out any missing sides. We still want to figure out any missing angles. But we're going to have to look at a slightly different formula because there's two cases we haven't considered yet. Let's look at this problem. I'm not actually going to go through and solve it right now. I just want to look at it and pretend like I gave you this and we tried to solve it with what we know right now. Okay. What do you notice when you look at this table?
There's no full row.
There's no full row, right? So law of sines, you've got to pick two rows to work with. And out of the two rows that you pick, you can only be missing one thing. Okay? So try every combination you have. Say, all right, I'm going to just try rows 1 and 2. Well, good luck, because you're missing two things. If you pick rows 1 and 2, you're missing something in row 1 and in row 2. No good. Say, all right, I'll try something else. I'll just try rows 2 and 3. Same problem. You're missing something in row 2 and in row 3. So you got two variables you're trying to solve for at the same time. It's not going to work. Last thing you could try is rows 1 and 3. Well, row 1, you're missing something. Row 3, you're missing something. So the problem is, no matter which two rows you pick, you're going to be missing two things. And you can't find anything that you're missing because it's not like you can do Pythagorean Theorem to get C. We don't know if we have a right triangle. And you don't have two angles to add together to get the third. So with what we know right now, there's no way to solve that. Okay? Can't do it. So this type of problem that I just showed you, it's side angle side. It's SAS. Because if you were to sketch it, it would look like this. Again, not to scale. A, alpha, B, beta, C, gamma. You have a side, and the angle that you know is where the two sides meet. The angle is between the sides. So if you're thinking, well, we've done it before where he's given me a side, and an angle. Yes, we've done side, angle. That's what we focused on yesterday in the homework. This is side, angle, side. Same information. Two sides and an angle, different placement. Okay, so it's in different spots. Okay, and the other case that we wouldn't be able to do is side. Okay, for the same reason. Just kind of look at it. Imagine you knew this, and this. You wouldn't have a full row. You'd be missing something in every single row. All right, so there's another example. Side, angle, side, triangle on the left. There's a side, triangle on the right. So I'm going to give you the formula for the law of cosines. There's 3 different ways you can write the formula. But it's really the idea behind the formula you want to remember. Okay? Because if you didn't call the sides ABC, and you called the sides, I don't know, XYZ, well then I could write the formula other ways. Or if you decided to call the sides D, E, and F, well then I could write the formula 3 more ways. Like, I mean, you can write it as many ways as you want. I just want you to understand like the pattern in the formula, right? Not the actual letters in it. Okay, but for the pattern I'm going to show you, I'll do it with ABC for sides, alpha, beta, gamma for angles. Okay, so I'm going to start out with the formula that looks like this. It starts out C squared equals A squared plus B squared. Now, with what I've shown you so far, does that kind of look like anything? Yeah, it looks like the Pythagorean Theorem. And if I was going to go through the proof of the law of cosines, that's how I would do it. I would be using the Pythagorean Theorem to show you something. Now, we know we can't use the Pythagorean Theorem unless you have a 90. So it's the Pythagorean Theorem, but then there's this kind of like, I call it like an adjustment. You have to subtract something. And what you have to subtract is this. 2ab cosine gamma. Now, there's a pattern there. Okay, look at the pattern. One side squared equals the sum of the other two. Doesn't matter what you want to call them. One side squared equals the sum of the other two squared minus, and it's always twice the 2 that you just wrote right there. 2ab. And then the last thing, this is law of cosines, so it has a cosine in it, and this is always the angle across from the side you started with. So we'll look at the pattern if it starts with a C. We can look at the pattern if it starts with an A, if it starts with a B. It could start with a D, an E, an F, a Q, X, Y, Z. It could start with any letter you want to name it. But just follow that same pattern every time. Okay. So let's just try writing the pattern starting with the letter B. Right. So what would this one be? B squared would equal A squared plus C squared. So one side squared equals the sum of the other two squared minus, what would come next?
2 cosine beta.
2, and then the letters that you just used. So 2, the letters I just used were A and C. Cosine. And what would my angle be?
Beta.
Beta. It's the angle across from the side you started with. Cosine beta. All right, I'll do it one more time. I'll just repeat it with a squared. But again, just try to think of the pattern, because you might have a word problem where you don't use letters A, B, and C. So just follow the pattern. All right. So what would this one be? A squared equals?
B squared plus C squared.
B squared plus C squared. Yeah.
Minus 2 BC.
Minus 2 letters you just used right before it. Yep.
And then cosine.
Cosine of the angle across from the letter you started with. Right? You could do D squared equals E squared plus F squared minus 2EF. Cosine whatever was across from D. Right? But it's the same pattern every time. Okay, and that's the law of cosines. So you use that same pattern every time. Now, we're going to stick with just this today. You might get into a situation where you have a choice. If you ever have a choice between law of sines and cosines, I'll talk about what you should do when that comes up. Okay? But that's your law of cosines. And that's really it for explaining notes and formulas. We're just going to look at 3 examples, and that's it. Okay, 1 word problem and two regulars. One of these is going to be a side angle side. One will be a side side side. All right, so if I look at that, I mean, I can draw it out and figure out, okay, which kind of triangle it is. But if you just look at the table, how do you know it's not a law of sines problem?
Because there's no one full row.
There's no full row. Okay, there's no full row, so it's got to be a law of cosines problem. Now, I know that there's only 2 types of law of cosines problems. Side angle side, side side side. Which one does this have to be?
Side angle.
It's got to be side angle side because they gave me 2 sides and an angle, right? And I don't have a full row. That's the other key. So I know it's law of cosines, side angle side. All right, now when you have side angle side, you do have to find something first. You can't pick anything you want. All right. If we go back and look at the formulas, every version of the law of cosines, okay, they all use every side. If you're going to use the law of cosines, you have every single side in the formula. In the first one, there's an A, B, and a C. The second one has an A, B, and a C. And the third one has A, B's, and C's. So you use every side every time. So if you're missing a side, That has to be the only thing you're missing. You cannot be missing an angle at the same time. So, which version of the law of cosines could I use so that I only be missing one thing? One. I have to use version 1. If you pick version 2, you're missing the c and you're missing beta. If you pick version 3, you're still missing the c, and now you're missing alpha. Right? So with side angle side, find the side you're missing first. Always. Okay, that's how you always want to do it. So let's fill everything in. So we've got c squared equals a squared. Now, normally I would just do that and write 4, but the first time through I'll write everything out and then we'll simplify after. Plus b squared minus 2 times a times b. 2 times 2 times 3 times cosine of gamma, which is 60. Okay, now we'll do it out. In this equation, the letter is pretty much by itself. I mean, yeah, you're going to have to take a square root in the end. But all the arithmetic is on the right-hand side. So just follow, whoops, I said I wasn't going to do that out. If you did it out, it's fine, but I'll do it out in the next step. All the arithmetic is on the right, so follow the order of operations, PEMDAS. Exponents first, 4 plus 9, right, minus 2 times 2 times 3 times cosine 60. Okay, so all I did in that step was my exponents. What's the next thing you do after exponents? Yep, do all the multiplication. So we have 2 times 2 times 3 times cosine 60. Well, first, I don't know what cosine 60 is. Well, I do, but let's just figure it out in case we don't know what it is. Okay, cosine 60, type it in, and you get 1/2. All right, so now I'm just going to write that out. 2 times 2 times 3 times 1/2. Okay, I'm really writing out a lot of extra steps here. All right, now let's do the multiplication. Minus 2 times 2 times 3. How much? 2 times 2 times 3? 12, half. 6. All right. So we got 4 plus 9 minus 6. All right, so now the only thing we have left, we just add those and subtract in order from left to right. 4 plus 9? 13 minus 6? 7. So now we almost have c by itself. Last thing I need to do to get c alone is what? We're going to square root it. Now I'm going to put approximately equal because I'm going to round it. I haven't done any rounding in this problem yet. Now I will. So the square root of 7 is about 2.646. So writing out every single step like that, you had about 1, 2, 3, 4, 5, 6 steps. Okay. We probably could shorten that to 3 steps if we did some of the squaring and kind of in our head as we went. And I'll do more of that next time. Right, so C is 2.646. All right, now you've got C. You can find anything you want. Once you have all your sides, you can do any order you want. Okay, let's draw this out. Now, what kind of triangle was this to start? It was all right, it was a side angle side. Actually, you know what? I'm going to put it right up here. All right, so that's what we were given to start, side angle side. 2, 3, alpha, beta, and this was 60. Now, let's add in the other piece of information we know. 2.646. What other triangle is it now? It's more than side angle side. Yeah, it's now a side, 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 which is still what law? still law of cosines. It's one other kind of triangle too. Yep, we got that one. So we got side angle side. It is side angle or side angle. There's a couple ways to look at it that way. But it is side angle. What law is side angle? That's law of sines. So technically you have enough information, you could jump over to using law of sines. But what is it? What about side angle? What's going on with that case?
You could have two answers.
That's the whole thing where you got to deal with the two answer, one answer, no answer. So we don't want to use law of sines because we just want to avoid all that. If you use law of cosines, it will give you the right answer if you do it right. All right? You're not going to have to worry about all the two solution, no solution. All right? So even though you could do law of sines, if you're extremely careful, I wouldn't. I would stick with law of cosines one more time. Because once you get one of these angles, all you have to do is add it up and subtract from 180. And then you got the third one. Okay, so we could do alpha or beta. Yeah.
So once you get alpha, you just add gamma and then subtract by 180?
Yeah, that's the quickest way to do it.
Beta?
Yeah. Because you're going to have to use C to find alpha, and you're going to use C to find beta. So if you've already gotten C wrong, well, everything's going to come out wrong.
Yeah.
So
C is very important.
yeah, so C is important. All right. So let's find. Let's do alpha. All right. So let's scroll down. So to find alpha, we're going to be using the third version of law of cosines. A squared equals b squared plus c squared. Let's go back up. I'm going to square it as I go. So a squared is 4. B squared is 9 plus c squared. Now, don't take 2.646 and square it. You've got the answer for c squared right there. If you square 2.646, you're probably going to get like 6.999. It's 7, right? We already know that. So we've got a squared, b squared, c squared, minus 2bc. Okay, I'm going to do that part on the calculator as I type it in. 2 times b times c. Well, what's 2 times b? How much?
15.876.
Okay, I think you might have done the whole thing. Let's just do 2 times b first.
Oh, never mind.
6. And now I'll do 6 times 2.646, which is probably what you said. 2.646. So we get 15.876. Now, that's rounded, but it's okay. It's 3 decimal places. As long as you do 3, you're going to be okay. All right. So we got a squared, b squared, c squared, 2bc. Cosine of, what's my angle? Alpha. Okay, we're trying to find alpha. Okay, now this is a little different than the last one. This is more like solving an equation. The variable isn't by itself at all, right? The variable is mixed up with a bunch of stuff on the right, all right? So we got to work with the right-hand side a little bit. I've got some like terms. What could I combine for like terms there? Just the 9 and the 7. Yep. And what do you get if you combine those? 16. Now, this equation right there, this is usually where people make a mistake with law of cosines. Right? Let me show you a little bit simpler equation that's pretty much the same thing. Okay? 4 equals 16 minus 15x. This equation is almost exactly the same thing. A number equals a number minus a number times a variable. Number equals a number minus a number times a variable. Can you do 16 minus 15? No. 16 and 15x are not like terms. If that x wasn't there, then you could. But it's there, so you can't. So what would be your next step in that equation?
Subtract 4. No, subtract 6.
Subtract 16. Yep. Start moving things away from the variable. Put them on the other side. So the next step would be subtract 16. That's gone. 4 minus 16 will give me negative 12. Okay. And now what you have is something like this. Negative 12 equals negative 15 times something you don't know. So what would be your next step? Divide by the number that's next to the variable. Yep. So in our case, divide by negative 15.876. That's gone. Divide by negative 15.876. That's gone. You can cancel the negatives and make them positive. Now, what I usually do with this step is look at that number. Okay? If you look at that number and the top is bigger than the bottom, you have a problem. Okay? The number in the bottom should always be bigger. If it's not, don't even continue because it's not going to work. So the number in the bottom is 15, the number in the top is 12. The number in the bottom is bigger, so that's good. Okay, so let's keep going. We've got 12 over 15.876 equals cosine alpha. Okay, but what I want is alpha. So what do I have to do on both sides?
Oh, take the inverse cosine?
Yep, take the inverse cosine. So inverse cosine, inverse cosine. This cancels that. And see what you get. Just be careful you don't get inverse sine. Okay, because you get into the pattern. We've been doing inverse sine all week. That's inverse cosine. All right, so second inverse cosine, 12 divided by 15.876. Doesn't really matter if you close the parenthesis at the end because there's nothing else coming after it. If we're going to round to 3 decimal places, technically that's 40.900. It would round up. It's 40.900. Okay. And now what I'm going to do is I'm just going to take the two that I have, add them up and subtract from 180. So that adds up to 100.9. Take 180 minus 100.9 and you get 79.1. 0, 0, again to show our accuracy there. Precision. And that's it. That's a law of cosines problem. Out of the two types, this is, I think, the harder type because you got two different things you got to do. Okay. One time you go through it, the letter is on the left. Okay, so you're solving for a side. The next time you go through it, the letter is on the right, so you're solving for an angle. So you got to do both. Solve for a side and solve for an angle. When we do side, 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 you're not doing both. You're solving for an angle every time. Okay. So to solve this one, how many times am I going to have to do law of cosines here at a minimum? 2. I'm going to have to do it at least twice. Which 2? Doesn't matter. Any 2. And then once you know 2, you can add them up and get the third. Now, can anybody think of a case where I give you side, 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 and you would only have to do law of cosines once?
isosceles triangle?
Yes, if it was an isosceles triangle. Because if two of the sides were the same, then you know two of the angles are the same. So once you have one angle, boom, you automatically get the second one. And then you can get the third one. So if you're given an isosceles triangle, keep that in mind. You don't have to go through the problem twice. But this is scaling, so we got to do it twice. All right, so we know A, we know B, we know C. Go back and look at your formulas. You know everything in every formula up to that line. You've got the A, the B, and the C. So you can pick any one that you want. And the nice thing about side, side, side is if you make a mistake on one thing, it will not affect anything else. So we're going to find alpha, or we could find alpha first. Once you find alpha, you're done with it. You don't use it ever again. To find beta, you use A, B, and C. To find gamma, you use A, B, and C. You never have to use anything you find to find something else. So that's always good. Okay, so let's pick, Ben, which angle do you want to find first?
Alpha.
Alpha. All right, so we're going to find alpha. Okay, how does the law of cosines start if you want to find alpha?
A squared equals 3 squared plus 6 squared.
All right, so a squared, yep. And you know what? I'm going to do it as I go. So a squared equals, and what did you say next?
3 squared plus 6 squared.
So 3 squared plus 6 squared. Okay, minus?
Do you want me to keep going?
Yeah.
Okay. Minus 2 times 3 times 6.
So 2 times 3 times 6. I could have just done that as I went if I wanted, but we'll do it after. So 2 times 3 times 6.
And then cosine alpha.
Cosine alpha. Okay, so we get 16 equals 45 minus, what's 2 times 3 times 6?
36.
30 what?
36.
Yep, 36. And now, since we did some of those steps as we went, we've already condensed the problem down pretty small. There's 3 steps left to get alpha by itself. If you can do all 3 at once, go for it. If you need to do one at a time, that's okay too. But what would my next step be here?
Subtracting 45.
Subtracting 45. So that's going to give me, let's see, 16 minus 45 is going to give me negative 29. Okay, 2 steps left.
Divide by 36.
One more time, divide by what?
36. Negative 36.
Negative 36. 36 and the negative is gone. On this side, the negative is gone. Bigger number is in the bottom. I like that. It's good. If the bigger number is in the top, you're going to get an error. Won't work. And you should never get an error. So if you get an error, you did something wrong. So you got 29 over 36 equals cosine alpha. 1 step.
Take the inverse cosine.
Take the inverse cosine. Inverse cosine. Gone. Gone. And we'll see what the inverse cosine of 29 over 36 is. Second, inverse cosine. 29 over 36. Okay, so that angle is 36.336. All right. Okay. Devin, what angle do you want to find next?
Beta.
Beta. Okay, so we're going to find beta. Is there anything someone could tell me about beta based on what I know so far? Yeah?
Being even smaller than alpha?
It's going to be smaller than alpha, so it's going to be smaller than 36. If you get something bigger than 36, something went wrong. Okay, something went wrong somewhere. All right, so let's find beta. Okay, so we find beta. Okay, so that one's going to start out b squared equals a squared plus c squared. So I don't have to scroll up and down. Can someone tell me what's b? So squared equals, what was A?
4.
So squared, and what was C?
6.
6. So B squared equals A squared plus C squared minus 2AC. So 2, 4, 6, if I remember right?
Yeah.
Cosine beta. Now we do it out just like we did last time. So Kyle, what's the first thing I could do here? Yep, and what could you simplify on the right-hand side?
2 times 4 times 6.
Even before that, we're going to do that one next, but there's one thing I see going left to right I could do before. You could do the 2, 4, 6 first if you wanted, but anything else you see before that?
36 minus 3. Or 16 plus 36.
16 plus 36, yep. Let's add those up, and that's going to give me how much? 52. So 52. Now I'll simplify what Kyle said at the same time. 2 times 4 times 6, it's 48. Alright, so now we got 3 steps left. Okay, what's my, Connor, what's my next step?
Simplify 52 minus 48.
No, we can't do 52 minus 48. Just like here, we couldn't do 45 minus 36. So do you see what we did at that step? All right. So you see what we got to do in this step?
Yeah, you subtract 52.
Right. You got to move the 52 to the other side. So that's gone. 9 minus 52. Get negative 43. Kayla, what would I do next? Second to last step.
Take the inverse.
We can't do that yet because we don't have cosine by itself.
So divide by negative 48.
Yep, we got to divide by negative 48 first. So cancels that. Cancels the negatives. Cancels the negatives there. Again, I'm looking at it. Okay, bigger numbers in the bottom. That's always a good sign. So 43 over 48 equals that. Now what can you do?
Take the inverse.
Yeah, now I can do the inverse cosine. Inverse cosine. Inverse cosine. Gone, gone. So inverse cosine of 43 over 48. And remember, we're looking for something smaller than 36. Does anybody have what that comes out to?
26.384.
Oh, thank you. 26.384. Now, if you're really not confident and you're like, you know what, I don't know, I might have messed those up, you can find gamma the same way we did the other two. You can go back and use A, B, and C. All right. But what I'm going to do is I'm just going to add these up and subtract from 180, which means if I got one of them wrong, then I'm automatically going to get this one wrong too. All right. So it's faster to just add it up and subtract from 180, but it's safer to go back and use A, B, and C because you're sticking with stuff that was given. Okay. But I'm pretty sure that those are good answers. So we got 36, 336. 26, 384. Add them up. We get 62.72 and subtract from 180. So you get 117.280. Okay, so side problem can be pretty repetitive because you're doing the same exact thing 2 or if you choose 3 times in a row. But you're always finding an angle. Side angle side, a little bit of variation. One time you do the side, the next time you do the angle. Okay, so any questions on those 2 types? Side angle side, side side. You'll have a minimum of 1 of each on the test, but one of them you'll have twice. because I'm going to give you 3 law of sines, 3 law of cosines. All right, so let's look at the let's look at our last problem, word problem. Okay, so for this one, the idea is we're trying to find the distance between 2 points in front of us, right? Now, maybe you'd say, well, why don't you just go use a tape measure and measure the distance? Well, maybe you're on one side of a canyon and you can see the other side and the side you're on. You want to know how far across the canyon is. You're planning your motorcycle jump. Okay, so you got to know how far it is. So it's not easy to get a tape measure across it. You don't have a helicopter to kind of do that. You don't have your tape measure shooting gun, so you can't shoot the tape measure across. So we're going to just figure out a way to get the distance without any fancy equipment. So maybe you've got a house on one side and a house on the other side of the canyon. Or if you don't like canyons, maybe it's a river. And there's alligators in the river that eat boats. So since the alligators in the river eat your boat, you can't take a boat across the river. So you just got to stay safe on one side. But it's good because the alligators are afraid of land, so they don't come out of the water. So from where you're standing, okay, to the 2 points that you want to measure the distance between in front of you, it's a 70-degree angle. So like if I wanted to know the distance across the back wall, or that wall of the classroom by the windows, I could stand here, shoot a laser to one corner of the room, look at where my laser is pointed, turn it, shoot it at the other corner of the room, and look at how much I turned it. That would tell me the angle for what I'm looking at. Okay, so that angle is 70 degrees. Okay, and then the person that's measuring the distance, they could either walk the distance, or usually if you can see the object, you know, the laser, it can tell you how far away it is based on, like, if it has a rangefinder and you point it at something, it'll tell you that wall is 23.4 feet away from me. It can just tell it. The surveyor doesn't even really need to walk. So, but the surveyor knows the distance from where they're standing to one spot and from where they're standing to the other spot. Okay, they know those distances. They just don't know between them. Okay. So the distances between from where you're standing to the 2 points are 50 feet and 70 feet. So it's kind of like you know an angle and you know two sides of a triangle, but what you really want is the third side that's out in front of you. Okay, that's what you're trying to find. So, what's that distance in front of you? How far apart are the two houses? Now, in our particular problem, again, I mentioned all kinds of reasons why maybe you can't just measure the distance directly, whether it's the alligators. Well, there's actually poisonous tree frogs. And
so you're saying no one lives in the other houses, though? Just have the people that live in those houses go inside.
They're afraid of the tree frogs. They know
it's always in their house.
Yeah, they have a wall that tree frogs can't get across. So they actually can't even get in this area because it's just too dangerous. And the tree frogs are huge. Like, they're the size of the house. So like,
That's pretty risky.
yeah, there's lots of them. Hundreds of tree frogs.
How do they build houses there?
It was an infestation. They moved in after. All right. So then you got the two houses, and you've got a third point, and that's where you're standing. Now, I said in the problem it was a surveyor. I couldn't find a surveyor, but I did find a World War II soldier.
Oh my god. He's trying to find his way home.
Yeah, he's a German trench soldier, I think. So
I'm sure they're probably here.
that's the surveyor. Okay, so the surveyor knows the distance from where they're standing to that house and to that house. Right? What are those distances? It says the surveyor knows the distance to houses A and B. A is 50, B is 70. That's what respectively means in that order. So A is the 50, B is the 70. Okay. 50, 70. And the surveyor knows that angle ACB is 70. That's the angle from where they're standing to the two houses. Okay, so how far apart are the two houses? Yeah, rivers.
There's no river in the picture.
No, it's not.
Well, it's this particular one is the poison tree frogs. So you could pretend it's a river or a big.
But
Yeah.
I thought you just couldn't cross it.
Yeah.
So that guy's gonna die because of the tree frogs.
So maybe it's not even a river. Maybe it's just like a lake, like a lake of fire or something.
Yes.
And the tree frogs live in the fire, so they're okay with it. But the people don't. There's a lot of peril in between these two houses. It's dangerous.
Why would you live there?
I'm gonna be so crazy.
What? He's loving this.
I love it.
So let's take this triangle.
If he's only 50 feet away from him,
That's pretty
I feel like that's not close enough if those tree frogs are bigger than a house.
Yeah, it could be. He could be in trouble. So we got to get this done quick. All right. So we've got 50, 70, 70, and that's the side we want to know. All right. So first thing we got to figure out.
Side angle side.
It's a side angle side.
No, I didn't do that.
So what law is that?
Cosine.
Law of cosines. So that's the law we have to use. Okay. So let's call this side x. I mean, you could call it A, B, C, call it whatever you want, but I just call it x. Okay, so remember the formula. One side squared equals the sum of the other two. So you start out with x squared equals, what's one of the other sides?
50.
50 squared
Plus 70 squared.
plus 70 squared.
Minus 2 times 50 times 7.
Yeah, 2, and then pick the two sides you just wrote.
Yeah.
So 250, 70, and then cosine of the angle across from the side you started with. 70. So we have everything we need except the distance between the two houses. Okay. So now numbers are going to be a little big, but we can use the calculator. Well, we don't need it yet. What's 50 squared?
2,500.
Yep.
I didn't know that.
And 70 squared?
4,900.
Yep, 49, and then just add 2 zeros. Like 7 squared would be 2 zeros. The next part, I think we're still okay. 2 times 50.
100.
And what's 100 times 70?
7,000.
Yeah. Just do 1 times 7 and put 3 zeros on it. So 7,000 times cosine 70. A little bit more we can do without a calculator, then we're going to need one. What's 25 plus 49?
74.
Yep, so we get 7,400 minus 7,000 cosine 70.
Cosine of 70.
All right, we can, at this point, let's type in everything on the right. Okay, all at once. Okay, we still don't have x by itself. We have one more thing to do. Let's just do 7,400 minus 7,000 cosine, what was the angle? 70. Cosine 70. 5,005.9. Roughly. Now, that's not the distance between the house, that's the distance squared. So last step.
Square root.
Yep, we'll take the square root. Now, I'm not going to type the square root of 5,005.9. I'm just going to do the square root of the last number that was on the screen. So it's going to be a little bit more accurate. So it's 70.75. We can round it to that.
So you're telling me a tree frog the size of the house can fit in 70 feet?
Yeah, these are what you call the miniature houses. You know, small homes.
house.
It's like the new thing. A tiny house. There we go. Tiny houses. These are tiny houses.
But that's still a big frog.
It is. It's very big
There's
frog.
an infestation of them
Yeah.
in a ring
And in a
of
ring of
fire.
fire, yeah.
What is this, Johnny Cash?
No, there's a pond that's on fire.
Remember, there's
Johnny Cash.
Ring of fire.
there might be like trees behind the pond too, so the frogs can be up in the trees. So there's a lot of room for the
That has to be a
frogs.
strong
Are you
tree.
recording this?
Yes.
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 This is the only one that's not gonna go up.
So you got a lake. You got trees behind the lake. Maybe there's even trees in front of the lake. So there's frogs everywhere. That's dangerous.
You wouldn't want to live in this
Lightning.
house.
It's bad.
Well, he
And
said
Harry
don't
Potter.
understand.
Like,
Like,
there's
there's
just
storm
storms
going
going
on.
on.
They moved in before they knew about the
Yeah, but-
frogs.
Yeah, it was
Houses
beautiful.
are
It was
literally
awesome.
on trailer hitches.
It was beautiful when they moved in, and then infestations and fireworks.
Size trees. Kill you in the ring of fire.
I'm waiting.
All right, so the problems for tonight, just those six: 9, 11, 13, 17, 25, 27. I will be here after school tomorrow if there's anything you need to make up. Last week's test, Friday is pretty much it. So you gotta get that done by Friday. If you need extra help, okay, I'll be here then. Also, if you have a study and you need to come by or before school, just let me know. And I'm here then too.